Okay, for number 21, they're asking us to perform the indicated operation and simplify if possible. That's always on our mind. We're always going to try to simplify things if we can. Here we're trying to add or subtract. In this case, signs are the same. We'll be adding, and we have common denominators, so we can add these. So you'll simply get, here's our common denominator, and in the numerators we have x plus 8, and that's all we can do. So this was a slightly unusual one in that you really couldn't go very far. If you had, alright, so here's a different one. Let's say x plus 8x, and let's put each of these over, we're just making up a number here. Let's have a 12 and a 12. Okay? In this case, you have common denominator, so you can add. Everything will be over a 12. You have 1x plus 8x, right? That's, let me emphasize, there's always a 1 sitting in front if nothing's there. So this would give you 9x over 12. Okay? And I think you realize that can simplify. Let me zoom out just a little bit here. So you can always cancel common factors. Well, it might be confusing to hear me say it that way. Usually what we just do is say, it means the same thing, but 3 goes into 9 and 3 goes into 12. So 9 divided by 3 is 3. 12 divided by 3 is 4. And this leaves you with 3x over 4. Regarding the common factor comment that I made, basically when you're working with rational expressions, you're canceling common factors. So to think of it in those terms, 9 can be written as 3 times 3. Okay, 12, there's many ways to write it. I could also write 9 as 1 times 9, but I'm interested in these common factors here. The 12 I could write as 3 times 4. And my x is sitting here. Okay, so all we really did was cancel common factors of 3 and 3. And that left us with 3x over 4. 3x over 4. Okay, so what we're really technically doing is canceling common factors, but usually we just say divide by the same factor. It's just easier to write and to think of that way. Okay? And we'll take a look at 22. Guess I don't need another piece of paper for this. We have common denominators. So this will all go over, well, let me zoom in a little here for you. I mean for this to interrupt our vision here. There we go. Alright, so 22, we have common denominators of 13 plus x. The numerators, we have 5 plus x plus 4. And these are like terms, so we can combine them. So we're going to get x plus 9 over 13 plus x. And there's going to be nothing else we can do with that. This is the simplified form of these two rational terms. Okay. We'll also take a look at 23. We have common denominators here, so we'll be able to combine like terms. Our common denominator is m plus 9. In the numerator we have 9 plus m. All signs are positive, so m plus 9 goes into 9 plus m one time. So these basically cancel, become 1s. 1 divided by 1 is 1. So that's your answer for 23. And we'll also take a look at 25 here. I don't want you too distracted with other things on the paper here. This is 25 we're looking at. All right, we have common denominator of x minus 5 and x minus 5. In the numerators we have x squared minus 8x. Guess I'm going to need this to be a little longer. And then plus 15. This plus is sitting right here, okay? And I can't cancel anything in this form. I can't cancel the 5 and the 15 because these are not factors. They're being added or subtracted, okay? But I can try to factor this numerator. If I can get the numerator to factor into something where one of the sets of parentheses is x minus 5, then I'll be able to cancel common factors. Okay, so you look at your 15, and we'll get some color in here. So your 15 can be written as 1 times 15 or 3 times 5. If they were both negative, that would give you a positive 15 and a negative 8x. So you'll have negative 3, negative 5. For the x squared, you'll take care of that simply with an x and an x. And then x minus 5 goes into x minus 5 one time. So the result is just x minus 3. So the simplified form, you could put x minus 3 over 1, but that's certainly not necessary. The most simplified form would just be x minus 3.